Hi, everybody. My name is Ryan Hollister, and I'm currently the secondary science instructional coach for the Turlock Unified School District. And this is my colleague, Eric Hauck, who is the K-5 instructional coach.
We're making great shifts in how we teach science using the NGSS framework written by the NRC, National Research Council. And it signals one of the greatest shifts, at least we've seen in the last 20 years, of how to get students to engage in science practices rather than just memorizing science.
So I guess one of the big things we're here to talk to you today about is what are some of the big shifts going on in climate change education as part of the NGSS and the Next Generation Science Standards. I'm going to speak to it a little bit from the secondary level, from middle school to high school, and then Eric can also add in a little bit about what's happening in the elementary levels. I think if you're not familiar with the Next Generation Science Standards, the big shift in that is a very student-centered type of science learning, where the teacher's role now is not the sage on the stage espousing factual information. Teachers have shifted into becoming facilitators, or will be shifting into becoming facilitators. Well, they'll provide students problems that are grounded in real-world phenomenon, hopefully stuff that is local and place-based, that is relevant to the students' lives, that will get them interested and engaged in trying to figure out, well, what's going on with, well, let's say wildfires is a good one that we'll talk about with climate change in a few minutes here. So how do these wildfires that happened this past summer and this past fall and winter, how do they affect our lives right here? So we give them the tools and we give them some data, and it's not just the old days of go research something. The teachers have to have an end point or a landing pad that they want their students to end on, and they give them they give their students the tools they need to be successful in that, whether it be data sets or data tables, and asking guided questions that will maybe prod the students along into making sense of what they're seeing in the data, so they're drawing their own conclusions, and it's not a confirmatory lab of, hey, this is what's going to happen. It's, what do you think is going to happen? What do you notice? What do you wonder? And how are you coming to your conclusions? And so they have to support and state a lot of their evidence. Within the Next Generation Science Standards, they really emphasize 8 science and engineering practices. And the science and engineering practices, I think, are the biggest piece of the NGSS. And I'll let Eric talk about the science and engineering practices really quick.
Engaging in practices is one of the cornerstones of the new framework. And this idea is represented quite well in the science and engineering practices, also abbreviated as SEPs. There are 8 of them, and these represent what scientists do on a daily basis. These progressions that Ryan just spoke about, I have a lot of experience working with them, K2 and 3.5 and 6.8. And in K2, we're focused primarily on, can they engage in the SEPs at this basic level with identifying patterns and cause and effect and trends. And then in the 3.5, we jump up to them being able to now use these patterns and cause and effect to solve real-world problems. And then especially in 6.8, that's where we really dive into some of the climate change underlying concepts. Especially in 6th grade, we are focused very heavily on air and water patterns that we see on our planet.
Yeah, those science and engineering practices give everybody the tools that they need, hopefully, to analyze and interpret data and make models and all sorts of great stuff. Another facet of the Next Generation Science Standards are called the disciplinary core ideas, which Eric just kind of touched on. And those are basically the main ideas, I guess, kind of the standards themselves, you might think of them as. in the past, I guess, is just the standards. That's kind of the concepts that we want the students walking away with that are specific to a life science, an earth science, or a physical science like chemistry or physics, which are lumped together. And all of these strands are between physical science, life science, and earth science, which is kind of one of the big tenets of NGSS, is combining all of these strands into solving a whole systems-wide problem. Eric has a little demonstration here about the physics and how the physics can affect climate change. And this is be 4th grade in the Turlock school districts that Eric developed.
Well, thank you for that great introduction on how intertwined the different subjects are. And this demonstration uses a radiometer. In 4th grade, the students started talking about waves and the patterns that we see in waves in both frequency and amplitude and wavelength, primarily wavelength. And one great way of talking about the wavelength and how it affects waves is using light, the electromagnetic spectrum. And so the radiometer is activated here by the light, and this is very much a shock to students that this can happen. And we would call this a phenomenon, something that makes them question, something that makes them interested in what's going on, and they want to do some experiments. And we're investigating specifically rainbows. And in this demonstration, the students get to experiment with different colors of light, which represent the different wavelengths that we see in the electromagnetic spectrum. So they initially start off with white light. However, then they get to experiment with different wavelengths by putting in filters, and they notice what happens. So when they see red, typically they'll notice a slowdown effect. And then when they see blue, they'll notice that it slows down, but not quite as much. And so this all ends up being data for them to analyze about the wavelength of light and how it can affect energy levels within a system. And the energy level is demonstrated by the speed at which the radiometer is spinning. So this becomes a real-world example for students about how light passing through different systems can transfer its energy to that system. And this is the beginning of how we start the process of talking about climate change in Turlock, which then leads quite nicely into the 5th and 6th grade standards that we will be addressing. What the students come away with is not only the difference in the electromagnetic spectrum and the energy levels of the different wavelengths of light, but they also come away with the explanation of why the radiometer is moving when exposed to light, which is because the black face of the two panels, the two-sided panels, will absorb a lot of the light's energy rather than reflect it like the white side does. And when the black side does absorb that energy, it's enough to vibrate the molecules of air that are in the partial vacuum of the radiometer itself, so that those molecules then push on that side so that it will spin in that direction.
So what Eric was demonstrating here provides a tremendous amount of background knowledge for our students that they may not have otherwise gotten in the previous iterations of the science frameworks. By the time they get to high school, students now will have been exposed to electromagnetic radiation. They'll understand that there's different wavelengths. And then to tie this into the climate change system, or how climate change affects our system, we'll be looking at the solar insolation and the electromagnetic radiation coming from the sun, and how that plays a massive role in the system that affects climate change. And we'll talk about how they can be absorbed, the different wavelengths can be absorbed by the different molecules of the gases in the atmosphere, specifically carbon dioxide, water, methane, things like that. So having this background knowledge, even though they may not be specifically talking about climate change with this lesson, it'll eventually tie back into a greater, what we call anchoring phenomenon. So all these little experiences that they've gone through their whole entire school year will then be used as background to tie in to solve one big overarching theme or problem that is kind of underneath this overarching theme. So in terms of implementation of the next generation science standards, in Turlock, this is our first real full year of working together to try to actually create our own curriculum. At the high school level, there is no curriculum that currently exists from a publisher. So we see this as an opportunity to create lots of localized phenomenon that are relevant to our students, that have everyday meaning to them, that are not just some generic examples provided in a textbook that's sold to the entire United States. The downside and the drawback to this is the teachers have had to work exceptionally hard this year and collaborate for huge amounts of time to come up with even a couple new lessons at a time. There's countless, hundreds of hours it seems like have gone in to just create a quarter-long unit. So teachers are a little bit tired. They're creative, and what they have to do is find all sorts of data that is relevant to their students. So it doesn't just exist. They're having to go research it on their own, create things that are interesting and engaging for their students. So it's hard, it's tiresome, and it's a huge, massive shift. But given enough time and given enough support, this is going to be an amazing change. And I think we're going to be having students churned out of our school system that will be critical thinkers, that can make wise science-based decisions, and hopefully become advocates for the Central Valley and know how their system that they live in works and contribute to that system in a positive and beneficial way.